that means that I could have gone in this. No, that's let's see for a second. So your presentation was supposed to go about 20 minutes. At about 20 minutes, I'll raise my hand and basically tell you the last 5 minutes. At about 23 minutes, I'll stand up so you got 2 minutes to basically wrap up. A little over 25 minutes, I'll cut you off.
No, if it fell on the ground, it's gone.
That's fine. It's okay.
Okay, it fell on the ground.
All right, welcome to the first batch of presentations for computer science. We've got 2 senior projects back to back. Very first one is going to be Ben Trebach, mentored by Dr. Lindsay Jameson on a WordPress client portal and some extra words.
Hi everybody, thanks for coming. My name is Ben Trebach, and my senior project was to develop a WordPress client portal. I wanted to make something user-friendly that would make the entire development process go a little more smoothly, both for the clients and the developers. First, a little background about myself. For the last few months, I've been working with a communications firm developing websites. My development has all been done using the WordPress Content Management System, or CMS. And I've made sites for clients ranging from property management companies to life coaches. As you can see, there's a process that I go through with each client. It consists of information gathering, design, development, and testing/deployment. However, throughout this process, I try to incorporate the client as much as I can to get their feedback and make sure they're happy with the progress I'm making. There's just one little problem. Client feedback takes forever and is rarely as simple as the client thinks. Seriously, some situations I've already encountered are after the client approves my design in Photoshop and I begin working on their site, they change their mind and send me an email asking for changes. Or say we have a scheduled feedback meeting, they give me some changes they want to see, and then a few hours later send me an email with more changes, some of which directly interfere with what we just talked about. Another issue is sometimes services are requested that just at a fundamental level were never agreed upon in the original contract. So I tried to come up with a solution to this problem. I developed this client portal for dealing with clients and all the paperwork that comes along with them. This page was designed to be used on a developer's staging server while they work on the site for the client. So a little information on servers. Most companies use at least a two-server approach. You have your staging server and a production server. The staging server is available from any computer, but under a different URL that is more commonly used, www.dev.companyname.com, as opposed to just www.companyname.com. It also requires a username and password for access, so it's closed off from the public. Since it's really only accessible by developers and clients, this is where development and testing occur. The production server, on the other hand, where the final site will reside, it will use the real URL and be available to the public, including search engines. This is why I decided to implement the client portal on the staging server. This actually allows the client to log in and view in real time the progress that's being made on their site. They can poke around and see it all firsthand without having to worry about changing anything accidentally. Here you can see my client Lindsay wants to log in and check out the progress being made on her new website. Upon logging in, the client is now able to see the full content of the site. This is actually the first hurdle I encountered with this project, and it led me to spend quite a bit of time with the WordPress codex, figuring out how the user system works. Eventually, I was able to understand the user role system, so I created a new user role called Client that has read-only access to the content. This grants the client access while assuring the developer that the client can't change anything. Here we have 2 functions, both written in PHP with some help from my good friend the WordPress codex that I use to configure the client role. The snippet on the left utilizes the add role function which is what allowed me to create a new type of role. Then underneath, I set the permissions to my liking. If you take a look at lines 4, 5, and 6, the client user has the ability to view, but not edit or delete content. Now on the right, we have the function I had to add that disables access to the WordPress administrator page, which is normally available to any logged in user. It took some figuring out, but eventually I was able to get this functioning properly to give the developer administrative access while restricting the client user using redirect, as you can see in line 9. So 2 of the major building blocks of any WordPress site are posts and pages. The client portal is meant to be included as a page on the client site, both for visibility and accessibility. This way it will show up along the top of the site with any other pages that have been created in the nav bar. As you can see here, we have the home page, we have the post page, contact us, and then lastly is the client portal. Here you can see the different modules that I worked on. On top, we have the communication center, underneath of which there is a file uploader and viewer, and then in the sidebar to the right, we have the progress tracker. The first feature I'd like to talk about today is the communication center. The goal for this feature was to replace the necessity for email communications with clients. Having one central location to store all the back and forths eliminates any chance of missed or buried emails. To accomplish this, I had to leverage the bbPress plugin, which is developed by the creators of WordPress themselves, to create an easy-to-use feedback area. Since it's based on a forum model, the developer can easily create a new topic with each updated version of the site. And there, the client can post back with any issues, feedback, or changes they'd like to see made. So this is what the client would see upon clicking on the latest version topic in the communication center. This is where all messages will be displayed and saved. Using the text underneath, the client can very easily post whatever they wish to communicate to the developers, whether it be a short text message, or pictures, or including links to other sites. So like, type it in the text area and hit submit. So both parties can see the entire conversation. Everything is kept in one place, and no longer do we have to worry about missing an email on a busy day. The next feature I want to focus on is the file uploading module. The goal here was to have a way for client and developers to share resources, whether they be pictures, site copy, contracts, whatever. When a user clicks on the Add File button, this prompt appears asking for a name for the file, if they want it in a certain folder, any notes they wish to add, and then a file browser to actually select the file from their computer. This information gets stored in an array, and before it gets uploaded, the server is checked for any files with matching file names, which would throw an error and ask for a resubmission. So here we have our fields filled out, where in this example, the client is uploading the contract, and as you can see in the notes section, it has been signed. So no file by the same name exists in the uploads directory, so it's accepted, and the user is given in a success message up top saying thanks. Now the file is visible and accessible to both the client and the developers, and this means no more lost paperwork. The last feature I want to discuss is also, in my opinion, the prettiest. Sometimes a client might not have the time to browse through an entire site and see how everything's going. I thought it might be nice for them to have a quick visual representation of where the developers are in the development cycle, and thus the idea for a progress tracker was born. The first step was I had to brainstorm how to break down a project into just a few short steps to represent visually. I ended up coming up with information gathering, design, development, and testing and deployment. These are easy to use as a quick reference for the client to see where the developers are in the whole process. I then created a custom widget so the progress tracker would be off to the side. I thought it made the portal look cleaner rather than stacking all 3 modules one on top of the other. Which you can see here. You can see the progress bar is located in the sidebar as a widget for page clarity. Alright, so here we have the code I used for each individual progress bar. The CSS snippet up top creates 2 elements, the first being the gray background and the second being the blue filling. The colors for both attributes are easily changed by hexadecimal values, as you can see in lines 3 and 9. For the blue filling that actually represents the progress, if you take a look at line number 10, this is where the developer updates the percentage completed. The HTML code below uses the div ID progress bar to display the visual elements, and then as you can see in the comments, text can be placed either above, inside, or underneath the actual progress bar. This was accomplished by separating the content with several divs, which created several areas. So throughout this project, I didn't really experience any major setbacks. One problem I did run into, though, was a poor WordPress update that rolled out. I believe it was from version 3.8 to 3.9. So when my site got updated, I lost a bunch of work that I had done, such as the work with user roles and progress bars. And this was totally my mistake because I hadn't taken the precaution to set up a child theme to develop on. I was developing right on the parent theme. A child theme is essentially another layer on top of your theme that your site is actually based on, the parent theme. You can add any custom functionality and visual attributes in your child theme, and anything that isn't declared in the child theme gets inherited from the parent theme. For example, if in your child theme you wrote a CSS attribute for all headers to be the color red, then on your site, all your headers would be red. If you don't change anything about the headers in the child theme, then they would be styled however they are from the parent theme. If I had used the child theme, my work would have been saved because only the parent theme would have been updated. In the end, I learned my lesson and made sure to use a child theme for the rest of my development. While this was definitely an inconvenience, it was easily remedied because I had been using Git for version control and had a repository on GitHub. With some more time, there are two things I would like to add to the client portal. The first is a more user-friendly backend, specifically for the progress bars. I think that it would be helpful to have some sort of widget on the administrative end that would allow developers to easily click or type in the percentage they would like to display completed for each progress bar. As it is currently, the developer has to go into the style sheet and manually change the percentage shown for each bar using CSS. The second thing I would like to do is set up the portal to be a custom page type. As it is, it only takes a few minutes to get it set up and configured correctly. I would know now that I've had to do it a couple of times. But if it were a custom page type, setup would be instantaneous. And then the last thing I'd like to do is release it for beta testing, maybe ask a few clients to try it out, and then give me some feedback, which I would then try to incorporate into a final release. All right, now it's time to see it in action. So here we have a new site for client Lindsay, and she wants a Washington Nationals fan club site, specifically for her husband.
Nationals took first place yesterday.
Yep, a crazy 3-hour delay. All right. So we log in. As you can see, content is currently restricted.
Very restricted.
It's very, very secure. I had to make this password nice because it's actually live online, so I don't want anybody getting in there. All right, so here we have our page. Now we can actually see all the content. Here's the roster, all this fun stuff. So let's say in this example, I'm the client and I only have a minute to take a look at things. So let me hop over to the client portal and check the progress tracker. Here you can see the progress bars are now red to match with the Nationals. And oh look, development's almost done. Maybe we should take a second and peruse the site a little bit and see if there's any last changes that we want to make. So we roll through the contact us page. Looks good, regular form, news. This looks good too. Home page. All right, this picture doesn't really have anything to do with the Nationals. So neither does that one. So let's go over to the client portal and upload some pictures for the developers to use. All right, so we go down to this file uploader, and for organizational sake, let's add a folder called Photos. Alright, so now let's add a picture or two. See this? I may have done this once or twice in practice. Alright, let's say for use in the home page slider, and now let's choose the file. Alright, so I'm gonna upload it. It's gonna check to see if there are any files by the same name, and if there aren't, it's gonna add it. We get the thanks message, and now down here, we take a look. Actually, we'll add another one just to make sure it's all working. And it's pick 2. I want it in the photos folder. Again, this is for use in the home page slider. And let's choose another one. Upload it. So a nice thing about this is that these files are stored easily in this file viewer right here that anybody can use, and also it's stored on the server in an uploads directory which the developer can FTP into and have easy access to download all the images or whatever it is. So now if we take a look at photos, we can see we have our 2 pictures in here. We can click on them to make sure it's the right thing. Here's a little preview, and then here we have our note right here that says for use in the home page slider. Okay, so now that we've added these pictures, let's let the developer know that. So let's go into the latest version in the Communication Center, and let's write, hey, the site looks awesome, because it does. But the placeholder images in the home page slider have got to go. I've uploaded some new ones to use. Alright, so now communication saved. The developer gets an email notification that there's been a new comment in this thread, and they can come and look at it whenever they have time, and the client can rest assured seeing that their post is visible right here. One last thing is that when, as I explained, with having to restrict the user roles, normally if any of you guys, I know some of you have experience with WordPress, if you would go up here, this would give you access to the administrative dashboard. But as you can see when we go, they've been restricted and they don't have any of the administrative options. That has been limited to only the developer user type. Alright, so that's pretty much the basic functionality of the client portal. I don't like that. Alright, I want to thank my coworker, Pete Saya. I spent a fair amount of time brainstorming features that would actually be helpful in our workplace with Pete. Together we came up with the outline for what we wanted the client portal to accomplish based on problems that we have both observed firsthand. And a huge thank you to Dr. Lindsay Jameson, who, well, our weekly meetings always kept me on track, and despite not having run into many problems, whenever I needed a little guidance, she was there to help me out. Overall, I'm pretty happy with how the client portal came out. I think it takes care of everything that I set out for it to do. And thank you all for watching our presentation. Any questions?
Did you consider having the client receive some sort of notification so that they know that the developer has seen any posts or changes or something like that? Like maybe a weekly email saying you should go check out your page because there have been changes or something like
Yeah, so once I was able to figure out how to get the email notifications going for developers, I hadn't really thought about it, but it would be easily implementable now, especially it could be one of these things where every time there is a new post in the thread, they could get a notification saying, check it out when you get a second, like, developers have responded to your comment.
So you've got these progress bars, right? How are those updated, and how are they actually, like, the actual progress sort of?
How do you decide on the amount of stuff in the progress bar? Or where that's?
Yeah. How is all of that stuff divided up? Right,
Well,
so like the incremental change in the progress bar?
For visual sake, I was just going by 20%, just because I thought that allowed for like an easy representation of, hey, we just started development, or we're like in the meat of it and we're almost done. It's really, right now, as you saw in the CSS, it's literally just a percentage, so it could be 37%.
Okay.
It could be, if you wanted to get like really down into it, it's just updated using the actual width of the oval.
So there's nothing linking that to like a task list, for instance?
No, not as of yet. That's one of the things that I wanted to try to add with a user-friendly backend for that would be ideally come up with a task list where each represents like 10%, 20%, and as you check them off, more and more progress would get filled.
Has this been tested live?
This is
By
oh.
no, by like a company?
No,
or?
it has not yet. I'm trying to finish up a few more things, and then we are planning on trying to, we're gonna ask clients first if they're okay giving this beta a test, and
Yep.
yeah, that is the plan.
Other questions for Ben?
My non-technical being?
You should choose the national.
Well,
Well,
Canadian. They were Canadian, okay, we can forgive them for that, but it's really because Alan is a huge Braves fan, and I despise the Braves, so. Yeah.
Why do you despise the Braves?
Because they can't beat you guys. It's very frustrating.
Any other questions for Ben? All right, thank you very much. Next presenter is
Hopefully you get the things he needs to present.
Yeah, that's making me less and less.
That was really cool.
I would be a client, I would give me access to it, I go in there and I go all your code and
Yeah, see, that's.
No, it's a child.
Yeah, it is. It's like, you can take away anything.
That's how often does that happen? They don't know,
Well, the thing is, right now.
I'm sorry, I don't really understand your question.
But like,
Well, explain that a little more, I don't get a little bit.
That's like,
That's
but that's
the process.
I think
Makes
that I
sense.
have down like one missed semicolon has brought a whole section.
You're not allowed to have it.
Wait, we always match.
Like,
Alan,
my
here,
one.
take the question
That's
left.
very true.
Oh my god, that means that my mom is going to ask me. That's really weird.
Yeah, that's
Well, so, kind of contract, and then try to do these things. So it's like small things, but then you really have to, we gotta do this like that, and then anything else, changes or. That makes sense.
Actually, that's a really important question.
I might just set mine up.
Until she starts singing.
I know.
Yeah.
I know.
What do you want to show?
So logistically, like, should we get a couple
turn the audio back on here. Our next presentation is Shay Bromer talking about Zombies Invade the Chess World, a two-dimensional computer game. His mentor was Dr. Simon Reed.
Alright, hi guys. Like Alan said, Shay Bromer. What I did for my senior project was a computer game. It's a pretty simple game. I'm going to start by just sort of going over the basic premise of it and how it was developed, and then I'm going to get into some specifics, and then at the end I'm going to demonstrate the game. So the basic premise is the user plays as a chess piece, and basically the sort of environment is just a standard 8x8 chessboard. And the idea is that zombies have invaded the chessboard, and you want to shoot at the zombies and not let them come near you. So the graphics in the game are pretty simple. It's all, like the title explained, it's all two-dimensional. Before the semester, I really didn't have any experience with graphics programming, so I tried to keep it pretty simple. And I also, what was more important was sort of trying to make like a complete game that could be played rather than focusing on the graphics. So the code base, in short, the game was written in C++, but with heavy use of OpenGL and GLUT, and I will eventually get into what those are. The IDE I used was Xcode tools, and I'll talk a little bit about that too. So in preparation, I first just took some time to familiarize myself with the code base I was using. Like I said, I didn't have any experience with OpenGL or GLUT, so that kind of took some time to just figure out what I was doing and even be able to do like very simple things. Sort of took some practice. I also had never used Xcode tools before, so it was a little bit of a learning curve there as well, but I actually have come to really like Xcode tools, and I think once you get the hang of it, it's a really good IDE. So just a little bit of background on OpenGL. It's an API for rendering two-dimensional and three-dimensional graphics. It works by interacting with the host computer's graphics processing unit. And OpenGL, it works very closely to the computer hardware. This makes it very versatile, but also a bit more complicated to use than some other graphics libraries. It's also cross-platform, cross-language. Basically just means it can run on any operating system, and you can manipulate it with a lot of different languages. Just some common uses for OpenGL are listed there. And I also have here, the first version came out in 1992, and there's been a lot of changes, and it was actually most recently updated last summer. Just a little bit of background on GLUT. GLUT is a library that is used in conjunction with OpenGL. It primarily handles input and output for applications that use OpenGL. So this includes creating windows, keyboard input, mouse input. For my game, keyboard input was very important. I used a lot of the sort of GLUT keyboard capabilities. And also, it is, again, cross-language and cross-platform. So now I'll just briefly go over the sort of structure of the code and sort of how certain things were implemented. So basically I had 3 C++ classes, a chess class, a zombies class, and a bullet class. And then also, so then all this stuff was sort of, I had an engine.cpp file, which is where the sort of main gameplay rules were implemented. And then, so there was also a vector of zombie objects, which was used to sort of control how many zombies there were and deal with getting rid of zombies after they'd been hit with bullets. So the chess class, this is just a list of sort of basic attributes that it had. There's a piece type, which just controlled which kind of piece it was. So, you know, you had pawn, castle, horse, bishop, king, queen. And the way the game works is when the game starts, you're randomly assigned a piece. So it's kind of, in some ways, it's kind of the luck of the draw. Obviously, some pieces are easier to use than others, like the pawn can't go side to side. The horse sort of jumps around. And then there's a display list in the chess class for each piece. Basically what a display list is it's a way to store a bunch of OpenGL calls, and then you can do, I think it's GL call list, and it'll just call, and basically it's just holds the display for the piece. So the zombies class, actually I forgot to talk about. So the chess class also had a row and column, and this was used to keep track of where things were on the board. So the way it sort of worked was the bottom left corner was 0, 0, and then, you know, but the top right would have been 7, 7. And so the coordinates in OpenGL are actually the very middle of the screen is 0, 0, and then, so the bottom will be -1, -1. So the way I sort of had the movement work was you would call a function called GL translate, which will translate the OpenGL calls you perform to a certain place on the screen. And so I would use the row and column, and I would do GL translate and then row times 0.25, and this would translate it to the appropriate place on the screen, like within the chessboard. So then the bullet class was slightly different. It also had a display, but it had X and Y instead of row and column, because so the zombies and the chess pieces would sort of just jump from one square to the next. So, but I wanted the bullets to sort of appear like they were like sliding across the screen. So they would be updated 10 times as much as the zombies and chess pieces, and this sort of allowed it to look like it was sort of continuously sliding across the screen. So here I have just a little code snippet to sort of explain some things. Here, the top, this for loop iterates through the vector of zombies. And so this is from the main display function, and basically this would be recall. So anytime anything changed, this is part of the function that would be called over and over again, and basically the screen would just refresh. And so here there's this for loop iterates through the vector of zombies, and it creates a matrix view, and then as you can see, the GL translate and GL call list functions that I talked about are right there. And you're multiplying by, so you're doing get row and get column, and then multiplying by 0.25 to translate it to the correct spot on the screen. So I'm just going to go over in more specific detail, the gameplay and the rules. So like I said before, you play as a random chess piece, just assigned randomly when the game starts. So you only have capability to shoot upwards or forward, depending how you look at it. But the zombies all come from the top of the screen, and basically you start at the bottom and you're shooting upwards and trying to survive as long as you can. You do have unlimited ammo, and the objective is just to survive as long as you can. And at the end, you are scored just based on how many, your score is just how many seconds you stay on the screen, basically. Okay, so now I'm gonna just demonstrate here. All right, so here you can see that I'm the castle. I'll just go ahead and play here. And then after I finish this, I forgot to talk about the sort of specifics of how the zombies work. Alright, so you can see here, my score was 43 seconds. So the way that zombies work is, there's actually, I should have talked about this when I had the list of attributes up, but so the zombie class has an attribute type, and it determines, so there's two types of zombies. One of them just moves randomly around the screen. It'll just pick a random direction and move in that direction. And then the other type has some degree of intelligence, and it literally just looks at where the player is and it moves the zombie in that direction. And then, so as time goes on, the ratio of intelligent zombies to non-intelligent zombies increases, and the zombies are also generated faster as you increase. So I was not able to get the play again button working, so I'm just gonna have to restart it again, but you can click to exit. All right, so I'll just demonstrate one more time. Okay, well, I'll just die right away since we already saw the castle. All right, so this is the horse, and as you can see, it jumps around. So one additional thing I need to talk about was, so when you're the king or the queen, so on a chessboard, king and queen can move up and down or diagonal. If you press the Z key, you can switch between moving diagonal and side to side. So I'll just try to do that until we get the queen or the king. Okay, well this is the pawn. As you can see, you can only move up and down. Well, I guess at this point I'll just open the floor for questions. Also, if anybody wants to try it out, people are welcome to.
Questions for Shay?
How did you determine the frequency of the zombies? Like, it was a trial and error to see,
Like how quickly they're generated?
Yeah.
It was basically just it was like almost like a timer. So you'd have, so there's something in glut called glut timer functions, and it's it basically just sets a timer, and then it will call the function after the timer's up. So I had a function like that, and then there was a variable that would get decreased each time within the function. So then then you would set it as the timer. So it would basically just, the timer would be less and less over time.
So is the purpose of the different pieces, obviously besides being a chessboard, is difficulty?
Yeah, I mean,
queen, you just like ruin everyone. But if you
right, yeah, exactly.
position,
So
you're already going.
it's a little bit of luck thrown into it. Right, so yeah, obviously some of the pieces you're gonna have a better chance for getting a high score than others.
So when you said you were assigned randomly things, did you take into account the probability of having a particular chess piece on the board so that you're more likely to get a pawn and really less likely to get a king or a queen, or was it really just random?
So the way, I don't know if I totally understood it.
So
but,
if you lay out a chessboard, you have 8 pawns per person and 2 castles, 2 horses, 2 bishops,
right.
a king and a
No,
queen?
no,
Okay.
it was just a random number between like 0 and 5, and then
A question from the stream. Can the speed of the bullets be altered? Seems really slow in comparison to zombie movement.
No. I mean, I guess I could have made them faster, but I kind of wanted you to be able to like miss. So if if you shoot upwards and the zombie's there, it can move out of the way in time, sort of. So you're not guaranteed to hit anything.
I'm sorry.
Go ahead.
What other features would you have implemented had you had more time?
You could have done sort of like power-ups or something. But you could have had, if you get to this certain square, you get, maybe faster bullets. Something I also thought about doing was making zombies where you had to hit them multiple times before they died.
What about like a leaderboard or something?
Yeah,
Like a-
right, yeah. Or yeah, keeping track of scores. I mean, there's a lot of different things you could have done with it.
Why did you choose OpenGL?
Simon suggested it to me, and I sort of looked into it, and it seemed like a feasible, and it seemed like a good, like if you didn't know anything about graphics programming, it seemed like it might be a good place to start.
In part because I was teaching an OpenGL class.
Fair enough. What was the core purpose for your senior project?
Just to make a game.
Just to make a game.
Yeah.
Other questions for Shay? All right, thank you very much. SMP start in 10 minutes.
Yeah, I didn't know.
Ben, where's my dongle?
What?
Where's my dongle?
I just left it.
You just left? Is it just up there?
Yeah, Shay was using it too.
No, it's fine. Leave it there. Other folks are gonna need it. Thank you.
Good job, Ben.
What?
Feel bad being Post.
Oh, no, I was about to go at it. Food.
I can't.
The things that I do for
It's
refreshments
like a
for
thing I'm
my
not sure.
SMBs. Yeah, no, like I literally did this just for the provided refreshments.
I feel like
See,
that's a bad idea.
I didn't do an SAP, and I'm still getting provided refreshments.
Well, I think I made some poor choices, is what I learned today.
Alan, what's the URL for the stream?
It's on the Facebook page.
It's on the Facebook page. It's sub.
I don't think we're allowed to
stream.
talk about this for another hour, but
Crappy
that not theory.
thing.
Oh, well, I mean, I turned mine in.
Yeah, I turned mine into zero.
One of the problems I know I'm not getting full credit for because it was the one where it was proved that the PQ torus knot isn't trivial. And I couldn't figure out a way to do it, so I was just like, well, you told us in class that the braid index of it is the smaller one.
I
Hey, Simon.
actually could do that.
Have you given us
Wow,
back
actually,
in that?
basically, if it's relatively prime, then if you try to draw it on the torus, it's going to intersect itself.
As we speak.
Because it's going to
Oh,
go,
nice.
like if you try and draw, like, say, like a 4-2, so it
I
goes
see
forward
what you
and
did there. That was
it goes
clever.
around the
Yes.
meridian
I'm
line,
about to.
for, like,
That's about as clever as I get today,
As you're
so.
shooting forward longitudinally, it's going to
Just wait till you hear my lemon
The
battery
four-
pun.
the four-
I only have one, but it's
Four
pretty
would be a
pretty
torus,
Winston.
Yeah, I mean, if you could draw it.
No, I forgot to put it in last night because I wasn't
Well,
looking
you
at
can
my
draw-
slides last night.
You can draw
A structure that goes around 4 times one way and 2 times another way.
But it would
It's
be-
just going to be a link.
Yeah.
Sean's there?
Is Sean's next?
Yeah.
I basically broke it down into how you create like a torus knot.
Slash, will they still be there at 4 o'clock?
So that, yeah, it would create, if you want to create that way, it would create a link, or it would just create a simpler knot, like a 4-2 would actually.
Thank you
make
for
a
sitting
2-1
on that side of the
sort
room.
thing. But yeah.
Yeah, it's always like
1C,
the professor
I ran out of time, I
comes in
couldn't get
this
1C,
corner,
and my
and
4C is
everybody's
super half-assed.
What was 1C?
1C was,
It's also like
find a way that, find a version that has more C-fert circles in the same genus.
So it was 5-2,
Building up from the front.
right?
Yeah.
So if you draw it as 5-2, you get
I kicked students out of
surface of the known
this
genus,
row.
we have 4
That's
cycles.
why there were students over in the.
But if you draw it as the
Then it's set up
braid,
as peanut gallery in
Then
the middle.
it's all
here.
3.
then you get 3 cipher circles.
Shit, wait, I thought you got 3 separate circles from the original one.
No, you get 4.
Oh, I don't know how
Power
separate
forward
circles
in my
work.
office. If you wanna pull it.
Like you get 3 faces, right?
Don't look at it. And that's why
I just like.
I mean, I don't know, you get 3 cipher circles.
Like practice.
Okay,
That's
no,
all.
but for drawing at 5-2, you get 3 faces. That's how you calculate, right?
Can I borrow your laser pointer?
And then 4C, you said? That was the one where it was.
Find an upper
He
bound.
wants a picture of us stressing out.
The easy upper bound is a minimum of Q minus 1 times Q over 2 and Q minus 1 times P over 2. Because since all torus knots can be represented as braids, you're either going to have P
No,
plus
I
1
got
times
that.
Q crossings or
Sorry,
Q minus
say
1
that
times
again.
P crossings.
See, I knew that, but instead of P minus 1 times Q minus 1, and now I can't write just for that. It was really stupid.
Yeah, so that's the answer that's in the book.
Well, no, the
And that
answer-
one's really hard. Well, P minus 1
That
times
over
Yeah, that's
2
fine.
is the answer.
Oh wait,
to
you
that.
used Q
Okay,
minus 1
so,
times Q minus 1?
Yeah.
Shit, that's like super wrong.
Oh, whatever. Well,
We are
it was
teaching
I mean,
it.
upper bound.
It is an upper bound. It's not,
No,
it's
I
not the
think
most
I'm walking along.
useful upper
That's
bound, but it is an
Alright,
upper bound.
I learned my justification for it. It was wrong, so I probably get that wrong then.
I was too nervous.
What I was thinking was what you said, but I don't know why I
You're
thought
gonna
you
email
could
me
combine
every other
it.
week.
No worries. But yeah, no, the test
And then we had to
was
come up with
You put it like
the
in the crowd
Yeah,
and
like
number
number 1, I honestly so I made the braid out of pop beads, and then I manipulated it, and I got it into a thing. And I was like, well, I know this is 5-2, but I can't figure out how to turn it into 5-2.
Do you need more
And so I just left
2
it.
seconds?
And then eventually I came back to it and I was like, alright, aha, idea. So I made 5-2 out of pop beads and manipulated it into the thing that I had.
I did the reverse. I had the braid, shook it. Oh, it's 5-2. Made the braid again, and then just started messing with it,
Okay.
and then
Oh,
like drawing steps out.
Yeah, I didn't draw the steps. I said I made it out of pop beads and did a series of isotopies.
would
and
love
got
to do
this.
more,
Like,
but
I don't know if
costs
that's
money
going
for
to be
credit.
full credit, probably not.
I think I'll get a little more credit for mine, even though
And
even
it's
eventually,
for
after like
credit for
5 steps, I
towards
got
the
frustrated. I was like,
generic,
hey, then it goes 5 too.
So,
Yeah,
yes.
no, like, with some of them, like, you would have to do
It'd be cool if
like
they had
pages and
towards
pages and
computer
pages.
science, but-
No.
Um,
We have less control over it, so we try to.
Let's see,
we
let's
want
see,
to
so
have
number
some
one wasn't
but
too bad.
We also want to make sure. that
Number
we're
2
right.
was, I remember 2 and 3 like being
Okay.
the easier
Let's
ones.
see.
I know I aced, yeah, I'm pretty sure I aced 2 and 3 because they were about polynomials.
Yeah,
Alright.
yeah, because the one where it was doing the polynomial for the hot flake.
A little bit.
Yeah, I was worried about the
Let's
polarization
say-
one because I was like, wait, I'm pretty sure you really calculated this because it looked at the determinant.
We were like,
It said so many determinants, and then I actually did the determinant, it was like super easy,
Let me
and I
think
was
about
like,
it now,
oh,
doing it out.
great.
But here's what I'm
Yeah,
thinking.
no,
Because
like
I
the
can't come
first
up
part
with
of
it
it, I was
like
actually
this.
like, man, why is this going to?
Yes.
I know, changing the direction won't affect it, but I don't
Not
understand
just
why.
the
Oh,
the testing
I was like,
materials
but changing
and
the
how
direction of it will make the
but
ride
they
negative.
come up
Wait,
with a
no.
one
Every crossing will go from being positive to being positive to
like
being
instead of
negative.
things like
Okay.
in the classroom,
So I got that.
instead of going zero to test it.
What was the other one?
In terms of how you test, what do you test, what sort of things can be tested, what
Two was
have to be tested.
Alexander polynomial and
What do you use to
and 3 was
document
X
that you
and Joe.
tested?
What did you get for
You
the
know what
polarization?
I'm saying?
It's
Yeah.
this morning.
So that's what I'm thinking.
because
at
it was
this point,
determinants
but I have to figure out how
what
that
it being
maps
and so
to.
that means it was 2 times
I didn't even
So,
use the
if
determinant.
you don't
I didn't actually take the determinant. What I did was like,
Oh, good news. I
so
think
you know you've got the circle and then you've got the twist one. So it's like, so because the circle means like the 2 sides of the twist
But if I
have to be the
have-
same as each other. Which means the middle of the twist has to be the same. Which means all, and I got that essentially every single arc has to be
I'm
colored
actually
the same.
debating taking the final, so push for the extra percentage points in A
Is it?
instead of
by yeah. Well, you know, it works because that logic would work well for a knot, but for lengths,
Yeah.
But actually
polarization
studying
is
this week,
weird.
getting things done.
Yeah,
So
okay, I did not get that one right then.
Yeah,
But
but
it's not a decision you
It's
have to
not
make
colorable.
until,
Sure, a knot's not
Monday
colorable
morning
or
anyway.
anything.
yeah, but yeah,
Okay.
it's all right.
Damn it.
in-laws and
Yeah, okay. My son is
Yeah, I was afraid that like when I saw it's 2 colorable and then I tried 2 coloring it, it's like, oh no, wait, 2 colors is
Yeah.
possible, and then I remembered that for like.
You have to remind Mama to.
Yeah, I don't, how is it different for legs?
I
Every
don't.
family
I can't
has the
even
crazy
remember. I didn't
family
even bother
members
looking
who
up. I just sort of
just
trust
use
the determinant principle. It's either calculated the determinant that
Funny, it
well,
translates
if it's going to be 8, that means
redirect
it's only
bonus
2
and
color. I mean, it's only the only prime colorization is 2.
here though, and it's only.
So.
Yeah, I considered doing it, but I was like, I don't want to take a 4x4 determinant.
Here's the thing.
Like, 4x4 determinants
I'm
aren't.
also not sure how long graduation's gonna take.
Yeah, but here's the thing, if you
Is
select from the
graduating
row
higher
columns eliminate
engineering?
right, you wind up like 2 of the headers would be 0, so you could
That
just
was what,
eliminate half the
3
row
hours?
right there. And then you go into the determinant that's full of 0s, 1s, and 2s. And it took me like 5 minutes to calculate.
Yeah, no, it wouldn't have.
graduation is
I think that's
longer.
kind of how you have to do it, to be honest. Because I think there's definitely.
Sorry,
If I tell you
the
start with
Alexander-
off like the Alexander
graduation.
polynomial, you could just put an angle towards like Alexander construction.
Yeah. It's the entire, it is the entire engineering college, including those
I
getting
think it was just like a
graduate
theory question.
degrees, so masters and PhDs. So
Because that's the last
There's a lot
part
of
tends to
people.
be is like, oh, what do you think about this, or explain this in your own
Though
words.
I will say that they do move quickly, efficiently.
I've had many years of practice.
Gonna be late, Sean.
Huh?
Gonna be starting late.
He's already late.
Come on, Sean, get it together.
Sean,
Yes, sir.
are you ready?
I am ready as soon as I open up this application. That will be out of here in my slides. Beam yourself. Beam myself, yeah.
Will the battery last for half an hour?
No, just recharge. If you charge it now, it will.
Oh.
we changed those values recently?
You can check it by just pressing the
Mhm.
laser pointer. Turn it on, make sure the laser pointer works.
Okay.
There's plenty of batteries.
All right.
Ready?
I'm ready.
All right, our next presentation is our first SMP presentation of the day. It'll be Sean Allred talking about a utility for the creation and evaluation of self-stabilizing algorithms. He hasn't even talked yet.
We're just so excited. I know, it's a great topic. I'm pretty excited about this tool. As Alan said, if you guys don't know me, I'm Sean, I think. Just about everyone in this room knows me. And Alan advised me on this SMP project I've been working on for the last year or so on self-stabilizing algorithms. All right, so let's give a brief introduction on how to use technology. Does the laser pointer work? Laser pointer works. Is this? Wow. All right. So, brief introduction on the domain here. We're just going to be talking about history. Oh, how about that? We're going to be talking about the history of self-stabilizing algorithms, a formal definition, and we're going to go through an example of how to actually run one of these algorithms in preparation for the other sections here, like how we're actually implementing it in the interface that I created to do this. So a bit of history about them first. A bit of history. Self-stabilizing algorithms isn't actually just one algorithm. It's an entire family of distributed algorithms. And they're most effectively applied to connected sparse graphs. And we'll see that this idea of sparseness, like not having too many connections, is kind of important for these algorithms to really work well. It's not, like obviously we don't have a very good definition of what sparse means, but if you have too many people talking in a room, not much is going to get done, if that makes sense. And again, these are called self-stabilizing systems. And for a long time, they were just called fault-tolerant systems. As far as I understand, Dijkstra was actually the one to introduce the term self-stabilizing as far as like dealing with these types of problems. And what so self-stabilizing bit is it will actually coerce the graph into a correct state. And the fault-tolerant bit is if something goes wrong in the graph, like if some outside force changes the state of one of the nodes, it'll actually correct itself, so nothing will be sad. Like I said before, each node is semi-autonomous. And I say semi because while each node can make its own decisions about, like, yes, I can make a move now, like, yes, I'm able to do something here, oftentimes we think about it in terms of some sort of central daemon that says, okay, node, you move, you move, you move. And this is how I've actually implemented it in Python, as we'll see. This actually isn't entirely necessary for the mathematical definition of what a self-stabilizing algorithm is, but we don't have a million brains to think about a million nodes all at the same time, so it's easier for us to think about it with this sort of serial daemon. Along with that whole million brains thing, these algorithms, because they're distributed algorithms, they are inherently very parallelizable. Each node makes its own decisions and it can make its own moves without any interference from the outside world. And this makes them very, very practical for real world situations because you often don't have some central process lording over everything else saying, okay, you go, you go, you go, you go, and etc. Like I said, it's often easier for us to just think about it as some sort of central daemon. So in 1974, Dijkstra introduced a paper called Self-Stabilizing Systems in Spite of Distributed Control. And that distributed control bit is that central idea of you go, you go, you go. But this paper actually went unnoticed for about 10 years until Leslie Lamport drew attention to it in an ACM talk in 1983, late October. It was only published in 1984 as a transcription. He called it Dijkstra's most brilliant work. I think he later added those. Probably it's just his most brilliant unpublished work. As you know, Dijkstra is kind of a big name in CS. So what is a self-stabilizing algorithm? Like, how did Dijkstra think about them? Well, we have these concepts of functions of a node and its neighbors, right? And then we have the algorithm itself as a collection of these rules. We have predicates and moves as these functions, and we can see predicate is just a function from a vertex and the neighborhood of that vertex, and the value is true or false. And move is just gives V a new state. And it's important to recognize that the move cannot alter the state of anything else surrounding it. That would very obviously cause concurrency issues like race conditions, like what if two nodes are trying to write at the same place at the same time, who goes first? So you can only write to yourself. And when this predicate is present, like when it's true, it's called that the privilege is present for that node. That node is able to make its move, theoretically. And these algorithms are defined by a collection of these rules, these mappings from predicates to moves. And it's not a proper function, as you would say. Like one predicate can map to multiple moves, and we'll see how that's implemented later on in the software solution. But we can just see that the algorithm is very simply an unordered set of these rules. So how do we actually run with these algorithms? First, we receive the graph in some arbitrary, possibly illegitimate state. Then the central daemon, as we think about it, chooses some privileged node P, right? And the nodes know whether or not they're privileged, so they report back to whoever's controlling this, if anyone, if they're privileged or not. Then P makes its move, and we repeat the whole process over again. So I'm going to go through a very, very quick, hopefully very quick example of a very simple self-stabilizing algorithm. It only has two rules, but we'll actually look at the definition first. So as most of us probably know, an independent set is a set of vertices in a graph such that no two nodes are adjacent to one another. Variant on this is a maximal independent set, meaning that, well, technically it's an independent set that is not a subset of any other independent set. But what that basically means is you have an independent set where you can't mark any more nodes. That's as much as you can do. So what's the actual algorithm for doing this? Well, as I said, for nodes have their own state. We have some local state marked, right? Like whether or not you're in the set. And we have two privileges, enter and leave. If we're unmarked and our neighbors are unmarked, then we can mark yourself. If you're breaking a rule, if you're marked and a neighbor is marked, then unmark yourself. And we'll just go through here. We have an arbitrary graph. Right now we look at this. We have three vertices with privileges present, V1, V4, and V5. All the privileges present. The marked ones can leave, the V5 can enter. And we arbitrarily choose V5, it makes its move, and it enters. And we arbitrarily choose another because the process is repeated. And it just chose V4, and we look at the graph again, and there are no privileges present, so it stops, it halts. So how is this actually implemented in the logic, the heart of what I did this year? We're going to go through like a brief overview of the actual implementation and an example using independent set, like how would that actually be represented. So one of the main problems I came across early on in the project was how do I actually represent these algorithms? You know, like there's a couple of different options. You can go straight mathematics, you can do like just some awful binary data serialization. And I looked at a lot of these options. First and foremost, actually, I looked at mathematics, but mathematics is actually pretty difficult to parse. It's difficult for a computer to parse when it is easy for a human to enter. There's technology like MathML, but that's very, very verbose, and no one wants to write that. More so, it's potentially ambiguous. Like if you have some function called mark, then you have no way of differentiating, well, no real way of differentiating between whether the node is marked or whether you're like applying the function marked, right? And frankly, it can be very, very dense when written formally. You know, you have a bunch of math on the screen. There's no really intuitive understanding of what is going on. We have a lot of privileges and moves and things like that going on. So it's apparent that we need a new system to overcome these obstacles. So what this new system needs to be, it comes down to basically three things. It has to be accessible, it has to be extensible, and it has to be sensible. It has to be accessible in that it shouldn't be tied to any particular platform or any particular technology, because one of the major goals of this was to have a a baseline for more things to be added onto this tool later on that people can understand, people can access, people can make real use of. And that actually goes with the extensible bit too. And the sensible bit, it really should make sense. Like having a binary serialization doesn't really make sense in this scenario, at least to me. So I just chose to implement predicates and moves as simple Python snippets. There's no function header, there's no anything, it's just do these things to this node. The functions, the vertex and the neighborhood is supplied to the function at runtime. And the algorithms themselves, I actually chose to implement as a YAML data serialization. You might ask me, okay, what is YAML? Why YAML? YAML is a plain text data serialization format. It is actually very, very readable, and because of this, it's a quickly growing standard. Because it's readable, like manual editing is feasible. Like for a large part of this project, I was simply creating the YAML myself, and it was made perfect sense. And manual editing is feasible. And more so, because it is a data serialization format, because it is this quickly growing standard, there are already a lot of parsers available. In my project, I actually used a library called PyYAML, which is pretty cool. So let's look at one of these, like part of this YAML document. We just declared two predicates here, like node should mark and node should unmark. And we actually tell the program where to find these scripts in the system. Right? We just give a file there. And what does one of these scripts look like? Well, we have a simple folder structure like inset.ssax. It's just a folder, it's not an actual file per se. And in the predicates directory, we have this file called enter.py. And these things are what needs to happen. So marked is v@marked. It has an attribute there. And neighbor mark that's basically saying if any node in my neighborhood, this capital N here, if any node in that neighborhood is marked, then that is true. And so we want to enter if we are neither marked nor one of our neighbors are marked. So that defines one of the predicates. And notice that the predicate has to have a return statement. If it doesn't have a return statement, it will always be false because Python thinks none is false. And that makes sense. And moves are very, very similar. You have names, file names, excuse me, and then you have their scripts and the moves directory where you just set the state of that particular node. And the interesting bit is actually the algorithm representation here. So we give the algorithm a name, we say, okay, we have this rule, that rule, and the predicate for this rule is enter, and we actually just give the name of the predicate that we gave earlier in the document. And we give a set of moves that it's able to do. And it'll only go to one of these moves, but it'll go to these moves. Okay. So how is this actually executed in the code? Well, briefly, overview. First, we find a list of all the privileged nodes. We apply all the predicates there. Each node decides whether or not it is privileged. Make sense? And then we select a random rule that vertex satisfied, right? And within that rule, each rule, as we saw earlier here, has a list of moves, and we choose a random move in there to execute. Right? And these, according to self-stabilization, theoretically, it doesn't have to be random, but it is arbitrary. And one of the things you have to think about when proving one of these algorithms is you have to suppose that whoever is controlling this process, if anyone, is choosing the worst possible move. So we just choose a random one to do that. Then we just execute the move. We calculate the change in the graph that it had, and then we add this change to a class I called animated graph, which is just a subclass of the NetworkX library's graph object. NetworkX is a very popular graph manipulation library for Python. It's pretty cool. So how this actually translates to code? Well, we just very simply look at all the vertices in G, and we look at all the rules in the algorithm. And if the rule applies to this vertex and the neighborhood of that vertex, we add this rule to the privileged nodes there. Privileged nodes is a dictionary indexed at nodes. So if we don't have any privileged nodes, if privileged nodes is empty, then we break out because the system has stabilized. And actually applying these things We choose a random node, we choose a random rule, and we actually apply the rule to the graph at the node. And that returns that delta object, and we add that delta to the history. All right, so yes. Text interfaces, while I personally really enjoy them, aren't incredibly intuitive to a lot of the people who are going to be actually using this piece of software. Like there are studies upon studies upon studies that graphical interfaces apparently are easier to use and make more sense to normal human beings. So yeah, why is it necessary? Not all computer scientists are programmers, and not all mathematicians have worked with code at all, right? And that, like a lot of stuff with theory of CS, you do get like really, really heady computer scientists, like absolutely brilliant, but maybe aren't as strong with the actual like complex control structures and things like that. They honestly could use their time elsewhere. And one of the things that we need to do for these people is we need to have a common interface to start from. We need to be able to say, okay, you can actually do this, you can make these rules this way, this is how you can do it. And it has to, one of the requirements for this interface, it has to be portable and cross-platform. It can't be, well, I didn't want it to be tied to any particular operating system or any particular platform or anything like that. It has to be at least supportive of the core features of the command line tool. Right? And most important of all, it needs to minimize the interface with the underlying YAML structure. Because just as those algorithms, those mathematical algorithms can get very, very long and very, very dense, that YAML document, that thing that says, okay, here's where you find everything, and here's how everything's related, as I found, that can also get very, very long and very, very dense very quickly. So, most importantly of all, the interface, since we're dealing with mathematicians and computer scientists, it has to have some correlation to the mathematical relationships that are actually going on. So, what does this look like? Well, I used Tkinter to actually create this interface, right? And we have a way to load bundles and save bundles with a relative file path here. And this screen is actually very, very simple. Once you hit load, it'll actually take that, the YAML file, it'll parse it, it'll actually execute all the predicates and moves and declare them in Python's scope. Right? Well, how do we make one of these algorithms? This screen. It's kind of dense, so I'm going to go through each piece individually. Well, we have a list of algorithms here, right? We can actually have multiple algorithms in that YAML document. There's nothing stopping us. And we have metadata for each algorithm. We have a name, we have who wrote it, and we have when they wrote it or when they last updated it. And each algorithm also has its own rules, right? We have a list of rules, we have the name of the rule, a date for the rule, author, and the predicate that that rule uses as a starting point. And it wouldn't be complete without the list of the moves that apply to it. Over here on the left, we have all the inactive moves, and this is just all the moves that are defined in the bundle, but aren't actually in the list of active moves that this rule will actually give out. So that's this screen entirely. Now we're going to move on to predicates here, and we have a similar layout here. We have a list of predicates that we have. We have a name for that predicate, date, description, author, and we have technical documentation. We have a file name that is actually going to be written to disk. And of course, we have the actual Python implementation of that rule, of that predicate rather. And it's exactly the same thing for moves. Literally nothing was changed. So further work for this, I wanted to be able to create a way to actually simulate, like visualizing the graphs real time. Right now, it can actually test these graphs, but that testing interface is completely text-based. Right? It spits out a list of deltas, and you can actually deal with that animated graph. But there's no way to actually see it in action, and that intuitive understanding of what the graph is doing would be very, very helpful to actually understand. That's actually pretty much all that further work. Does anybody have any questions for me?